Hi, my name is Ayana Deans. I'm a first year biology major from Philadelphia, Pennsylvania.
Hi, everyone. My name is Amoyo Donaldson. I am a first-year biology major from Philadelphia, Pennsylvania.
Hi, everyone. My name is Soraya Hawkins. I'm a first-year biology major with a minor in leadership studies from Wilmington, Delaware.
Hi, everyone. My name is Joshua Hurlock. I'm a first-year pre-med biology major from Albany, New York.
Hi, my name is Alex Mendez. I'm a first-year biochemistry major from El Centro, California.
And this is our presentation on bird of prey migration patterns in the Florida Keys. So our introduction states that bird of prey migration directly correlates with local and seasonal weather patterns. Since all birds are ectotherms, meaning they require warmer climates for their survival, they maintain a constant temperature of around 100 degrees Fahrenheit. During autumn, they start to mass migrate to areas of the globe that exhibit summer or spring temperatures. The cyclical nature of these migration patterns have allowed the GPS trackers, which are placed on the individual birds, to be laid dormant during months with minimal movement and retrieved for positional data during months observed with high reaching. Data tracking sources like satellites are largely beneficial to these types of studies because with the large amount of these machines orbiting Earth's atmosphere, these birds can be accurately tracked across the globe.
So the first thing we had to do as a group was come up with our research questions, and we ended up coming up with our main question being, how did COVID affect Hawkwatch data between fall 2020 and fall 2021? And our specific question was, which month between August to November do vultures migrate to Florida Keys? The second thing we had to do was choose our study site, obviously being Florida Keys, which is located in Little Croc Key, Florida, USA. The topography of the site is a coastal narrow low elevation with vegetation surrounding the site, which is a composed native grasses and mixed native tree species, primarily red mangrove or buttonwood. After that, we used hot count to collect our data, which we then used to create figures and charts using Excel to create a visual representation of the data presented in our site. The figures and charts were then used to help support our hypothesis.
Although table 1 is the most important table on our poster, we decided to go in the order that the information was approached. Starting from figure 2.A and figure 2.B, it gives a visual comparison through species accumulation curves of species abundance from fall 2021 and fall 2020. And you can see a common trend of bird abundance increasing as more species are taken and it gets later in the season. We even noticed that 5 new species were introduced into the observations in 2021, which were not seen in fall of 2022. Well, fall of 2020, sorry. Moving down to figure 3, we decided to focus in on the individual species. We noticed that black vultures and turkey vultures had a higher abundance in November than any other month. But when comparing them to frequency, as in figure 4, we noticed that more osprey were seen overall. So even though more osprey were more frequent, turkey vultures were more dominant in November. We then decided to use this information and create a correlation analysis using a scatter plot. So we wanted to kind of see what temperature created the most species richness and when species were in that area the most. We observed that around 25 degrees Celsius is when more species were in the Florida Keys, and we used that temperature as a basis for our discussion. We then used all of this information to create a diversity metrics table as the top figure, which was the most important to us. So we noticed as abundance increases, richness, diversity, and evenness begin to kind of hit a maximum and then start to slowly decrease. So as abundance is increasing and increasing, even as diversity and richness is decreasing because more species are leaving that area as it's getting warmer. Well, as it's getting later in the season, sorry. And we also wanted to just include a species list. We observed over 20 species.
So when it comes to the results bullets, what we were able to gather, as you can see in both the tables and the graphs, November has the most activity and diversity among the different species. So when we refer to a species or multiple species as top birds, we mean that we saw multiple or different numbers when it comes to those species. For example, we see that, as stated before, osprey were, I apologize, osprey were most dominant when it came to, well, we saw the most numbers. Yes, that's what I'm trying to say. And then when it comes to the month of November, we see that turkey vultures or vultures in general dominated during that month. Therefore, we were able to gather that top birds, quote unquote, were the osprey and vultures and other vultures or other birds as well. Another point that I wanted to make was that turkey vultures, peregrine falcons, and broad-winged hawks were the main birds to migrate through both seasons. So we had the early season and the late season. The early season consisted of the month of August and the month of September, and then the late season consisted of October through November. Therefore, we saw more vultures in November, technically the late season, and thus proves what we have to say.
Overall, in the later season, more towards November, migration of vultures increased. In the earlier season, osprey and swallowtail kite were spotted more than any other birds. Once the later season came around, turkey vultures began to dominate. The amount of species found has a direct relationship with the temperature, basically meaning the birds are in these particular areas because it's warm in those areas. Our hypothesis was not supported completely because migration was more prominent in the earlier months rather than in December, as we hypothesized.
In the end, we'd like to thank Dr. Dash for guiding us and being a great mentor. We also like to acknowledge Dr. Tolliver, Hampton University, Department of Biological Science and Hawk Migration Association of North America's Raptors.
And most importantly, we would like to acknowledge NSF for their funding